Now coming to some other factors which affects ionization energy. Already we have discussed two factors: across the period and down the group. Across the period increases, nuclear charge increases. Down the group, why atomic what you can say, that is the atomic size increases, but ionization energy, what happens is that decreases. Alright, because down the group it's affected by the number of shells, and across the period it's affected by the nuclear charge. Alright, but there are some other factors down the group also that I am going to discuss with you. Let me discuss this one first. Now, next is this third what you can say factors which affects the ionization energy is your penetration effect. The third is here. First and second discussed with you, the penetration effect. Now what do you mean by this? Penetration effect means what? Means to say, if an electron is present in the S subshell and if an electron is present in the P subshell, which will be easier for you to know the electron? P subshell. Why? Because S subshell is nearer to the nucleus and P subshell is further away. So if it is further away, definitely it is easier for you, just like atomic size I said. So for that particular reason, remember it, that is S subshell if an electron is there, then P, then D, then F, because the distance from the nucleus increases in this manner. S subshell is nearer to the nucleus, then P subshell, then D subshell, then F subshell. Alright, clear? So this is the what I have done it is here is that distance from the nucleus increases in this manner. Alright, if you move from the nucleus, then S subshell is always closer, then P, then D, then F. So it is, if an electron is present in the S subshell, it is difficult to remove compared to an electron which is present in the P subshell. Alright, let me give an example so that will be clear to you. Now you know, in a particular period, let me write the elements of the third period: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Correct. So now here it is, what you find is that atomic number 11, 12, 13, 14, 15, 16, 17, 18. Now the outermost only I require here. The outermost is here 3s1, this is 3s2, this is 3s2, 3p1, this is your little bit below I am writing 3s2, 3p2, and here it is 3s2, 3p3, here it is 3s2, 3p4, in this way it goes on, then 3s2, 3p5 and 3s2, 3p6. Okay, fine. I wrote the outermost shell configuration and written it. Now, you know that when you move from left to right across a period, just now I said, ionization energy increases or ionization enthalpy increases. But why? For example, I am asking you here, that is, why the ionization enthalpy of aluminium is more than that of magnesium? Why it is? You say, sir, we know that across the period increases, so it is increasing. No, you can't explain in that way. You have to explain on the basis of penetration effect. How? In case of aluminium, listen carefully. Listen here. In case of aluminium, now magnesium 3s2, aluminium 3s2, 3p1. So you are going to remove electron from 3p1, and here you are going to remove an electron from S subshell. So ionization energy of magnesium, got it, is more than that of aluminium or not? Or what you can say, ionization energy of aluminium is more than that of magnesium. You will say, sir, you only said across the period ionization energy is increasing. So definitely aluminium will be more than that of magnesium because it is increasing. Correct. Still I am saying that same thing. But here what you find, if you want to remove an electron from magnesium, you have to remove from the S subshell. And here if you want to remove an electron, then you are removing from the which subshell? P subshell. Which is nearer to the nucleus? S subshell or P subshell? S subshell. So if it is nearer to the nucleus, it will be difficult for you to remove an electron. Definitely, because this electron will be held strongly by the nucleus. This electron will be held strongly by the nucleus compared to the electron in the P subshell. So hence, here it is a exceptional. The ionization energy of magnesium is more than that of aluminium. Notice there is some exceptional also. Hence I took this particular one. Alright. Otherwise, we know from across the period increases. Yes, of course it is increasing. Who said it is not increasing? You compare aluminium and silicon. See, in aluminium and silicon, what you find is that 3s2, 3p1, 3s2, 3p2. Both are removing from the P subshell. Both. See, here also P1, here P2. from the outermost. Na? So here P1 and P2. Both are p subshell. But as the nuclear charge of silicon is more than that of aluminium, for that particular reason, what you find is that ionization energy of silicon is more than that of aluminium. That is according to the, what you can say, the regular trend, which I said that across the period increases. But there are some exceptional. Here is, you can see, exceptional. Magnesium and aluminium is exceptional. So here the ionization energy of magnesium is more than that of aluminium. Alright, now, so if you want to show this particular one graphically, then how will you show it? This particular one graphically. Similarly, you see here, one more exceptional I am going to give it to you. Now, silicon and phosphorus, if you see. Now, silicon and phosphorus, if you see, phosphorus, this is the electronic configuration, 3s2 3p3. Now, outermost is fully, what you can say, stable configuration, because it is half filled, exactly half filled. Alright, and here it is, silicon is what? Partially filled. It's not half filled, it's partially filled. Here it is partially filled and it's half filled here. You know, half filled configuration is a stable configuration. And stable means, will it be easier for you to remove an electron? No, it will be difficult. So hence, what you find is that phosphorus, for that reason, is more than that of silicon. Got it? So you will say, sir, this is according to the rule only. Yes, I'll come to the next one. Phosphorus and sulfur, you see now. Alright, now phosphorus 3p3, sulfur is 3s2 3p4. It is half filled, but this is again partially filled. How it's partially filled? See here, I am showing it. 3p means that is p subshell has got 3 orbitals, px, py, pz. How will you fill it up? 1, 2, 3 according to Hund's rule. So 1, 2, 3, first electron, second electron, third electron, fourth electron will come here. So it's not partially filled. Of course, in case of phosphorus, it is in this way, na? 3s2 3p3. See, 3p3. It is half filled. So which is stable configuration? Half filled or partially filled? Half filled. Half filled and fully filled are stable. So here it is stable configuration. Here it is unstable. So if it is having a stable configuration, that means more energy will be required to remove the electrons from that particular stable configuration. Alright, because it is, this atom is quite stable compared to silicon, as compared to sulfur, we can say that. So as it is quite stable, so to remove an electron from the stable configuration is quite difficult. Alright, because already it's stable. So hence, as it is difficult to remove an electron from phosphorus than that of sulfur. So hence, ionization energy of phosphorus is more than that of sulfur. It should be, sulfur should be more than that of phosphorus, na? Because across the period it should increase. But here again it's an exception, that ionization energy of phosphorus is more than that of sulfur. Got it? So when you will show this one graphically, then this sort of graph you will be getting it. I'll be able to draw a smaller one only because I don't have the space. Otherwise, I can do one thing. Let me rub it this one and let me draw the graph here. Correct. So for sodium, let us say this is your ionization energy. Alright, and this is your that is atomic number. We can say that. Alright, this is your ionization energy and this is your atomic number. Now we'll see the graph, what the graph it should be. Clear? So now you see here, let us say we are starting from sodium. This is your sodium. Na. It increases. Magnesium. Alright, this is Mg. Then after that, aluminium decreases. Just now we said you, magnesium is having higher ionization energy, and aluminium is going to decrease. It is coming down. Aluminium, this is your aluminium. Then silicon again increases. Phosphorus again increases. I am drawing a short one, okay? I don't have the space here. Then aluminium, silicon, phosphorus. Sulfur, it will again come down. Sulfur again it is going to come down. Alright, then it will be going up for chlorine and going up for argon. It will be chlorine and it will be argon. We can say in this way. This sort of graph you will be getting it. It's not exactly a straight line, but some deviations you can see in the graph is there. The reason I've said you already. So in a period when you're moving, definitely ionization energy is increasing because you can see the graph is going up. But there are also certain factors you need to remember. What is that? Penetration effect. Another is that is configuration. Whether it is half filled or fully filled. If it is half filled and fully filled, stable configuration means more energy will be required to remove the electrons from it. So all these factors you need to remember while writing the answers. And these questions generally come in reasoning. You get the questions in the reasoning questions, you get it. Alright. Now, next is, I hope you got it, this one. screening effect. After that, screening effect or shielding effect. Now what do you mean by that? First you write it down, the factor. When the screening effect increases, and the shielding effect or the screening effect increases of the innermost electrons, the ionization energy decreases. Again I repeat, screening effect or shielding effect, both are same, increases for the innermost electrons, or the electrons present in the innermost shell. Then the ionization energy decreases. We can say that. The ionization enthalpy or ionization energy decreases. Now what is screening effect? Like you have seen in your house, you are putting the screen. Or when you are going for a war, you are using a shield. ना? ढाल जिसको बोलते हैं. तलवार होता है, ढाल. Got it? किस लिए होता है ढाल? रक्षा करने के लिए. Got it? To protect yourself. Similarly, we are putting screen in your house to protect from what? Protect from the sunlight or any other insects or something like that coming to it. So we just have a screen. The screen protects us. Similarly, in a particular atom, let us say this is a nucleus and we are having the number of shells. Got it? If an electrons are present here, 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 in the innermost shell the electrons are there. Outermost shells also electrons are there. Got it? See, the innermost shell, these are the electrons. So, the electrons which are present in the innermost shell, listen carefully, will it allow the electrons which is present in the outermost shell to come nearer to the nucleus? The electrons which is present in the innermost shell, here you can see 3 shells are there, 1, 2, 3. The electrons which is present in the innermost shell, will it allow the electrons which is present in the outermost shell to come nearer to the nucleus? You will say why not? No, it will not allow. Why? Because it will repel. If these electrons will come closer to it, it is going to repel one another because electrons are of similar charges. Alright, so hence the electrons which are present in the innermost shell, it acts like a screen or a shield. So this is a screen, this is a shield for the nucleus. So this electrons does not allow the electrons which is present in the outermost shell to come nearer to the nucleus. Alright, the electrons which is present in the innermost shell, it does not allow the electrons to come nearer to the nucleus. It acts like a shield, it acts like a screen because the repulsion takes place. Alright, so this particular effect is known as screening effect or shielding effect. Alright, now very simple it is. Alright, the electrons which is present in the innermost shell, it acts like a screen or a shield to the electrons which is present in the outermost shell. It does not allow the electrons which is present in the outermost shell to come nearer to the nucleus. Why? Because I said it, very simple, repels one another. So hence it does not allow. So if it is not allowing, then definitely you can remove these electrons which is present in the outermost shell easily because you can see the distance is much more. Correct? Clear? So hence, as screening effect increases means let us say one more shell I will add it here. So this will go still further away. Means the electrons which is present in the outermost shell, this goes further and further away if the innermost shell is going to increase. So if the electrons goes further and further away from the nucleus, will it be easy for you or difficult for you? Easy for you. Because just now we have studied, as the number of shells increases, ionization energy decreases. Here also same thing now. What I said, screening effect increases means what? Innermost shell is going to increase. So definitely the outermost shell will go far away from the nucleus. As it goes far away, it becomes easier for you to remove the electrons from the outermost shell. So hence, shielding effect increases, screening effect increases, ionization energy decreases, so to say. Got it? So in this way, you learnt and what you can say screening effect or shielding effect. Now I said you that in case of atomic size, I said you that the string, I will say you one more factor. This is that factor. That when you come down the group, not only number of shells is increasing, but also the screening effect is increasing. So you will say, sir, nuclear charge is also increasing when you are coming down the group because atomic number is increasing. Fine. But the combination effect is that, the combined effect is that, listen carefully, screening effect increases, our number of shells increases. Alright, this two combined effect which increases, it, what you can say, overrules, alright, the nuclear charge. Alright, even if you say the nuclear charge is increasing when you come down the group, I agree with you that the nuclear charge is increasing. When you come down the group, the nuclear charge is increasing. Why? Because number of atomic number is increasing. Now, when you are coming down the group, number of shells is adding means atomic number is increasing. So nuclear charge is definitely increasing. Nuclear charge, you understand or not? Number of protons which is present inside the nucleus, and protons is positively charged. And hence nucleus is what you can say positively charged, which is known as nuclear charge. So when you come down the group, nuclear charge is increasing. But here That is, the number of shells and the screening effect predominates or overrules the nuclear charge, due to which, even if the nuclear charge is increasing, as the number of shells and the screening effect predominates, so hence when you come down the group, what you find is that it is affected by number of shells only, not by the nuclear charge. As the number of shells is increasing, ionization energy decreases, because as the number of shells will increase, you are moving away from the nucleus, ionization energy is going to decrease. Got it my point now? So down the group, ionization energy decreases across a period, it is increasing, but there are certain, what you can say, in between some deviations are there which I have discussed with you. Alright, that deviations, the reason I have discussed with you. Alright, I have told you about screening effect, I told you about the penetration effect. So these are the factors which affects the, what you can say, ionization energy. Thank you very much.